Kelechukwu and Esther. Okay, give me the next slide. Okay, so first of all, we have to discuss what is the aim of the project. Now, a temperature monitoring system is just we want to be able to use a sensor to get temperature of a particular body. So, the way that the computer is able to communicate all this, your device is able to communicate with the real world through sensors. So, once you're able to take temperature from the real world and be able to put it into the system as values that you can do something like you just want to get the temperature. So now the aim is to design and implement a real-time digital temperature monitoring system using a DS18B20 precision digital temperature sensor. Now, this is like we want to take the temperature, but then what the particular temperature sensor we're going to be using is a DS18B20. This particular temperature sensor, now, there are many types of temperature sensors, and this particular one is waterproof, and like it's written here, is digital, meaning that the values is going to be given, they are going to come as discrete values. The temperature sensor, it gets the temperature in the voltages. Inside the temperature sensor, there is a conversion system from analog to digital. So it converts it within itself and then sends digital signal to your microcontroller. So if you interface the DS18B20 to your microcontroller, what signal you'll be receiving from the sensor is digital. So that's why this one is very good. And like I said, it is waterproof. Now I'm going to be interfacing it with an Arduino Uno, and we'll be using a 16:2 LCD screen display. So we want to be able to get the temperature and display that exact temperature on a liquid crystal display. So the liquid crystal display we have like 18:2. This just typically means that it's 16 characters by 2 rows. So it has like 16 columns and 2 rows. So we want to be able to use this particular display. And so that once you pick up a temperature value, for example, you pick up 32 degrees Celsius on that waterproof, so you can submerge it inside water. You can submerge it inside liquids, and temperature sensors are waterproof. So when you want to build a system, you know what you want for, and then you get appropriate sensors. Now, what's the objective? One, the objective is to understand the working principles of 18B20 digital temperature sensor. Want to understand how does this temperature sensor, how does it work? Two is that we want to be able to use the one-wire protocol and a Dallas temperature libraries. We want to use the one-wire library and a Dallas temperature. We know. So for this project to be able to, we will install the two libraries. So be able to the temperature sensor. Now we're going to use I2C liquid crystal display. So the I2C is basically just a protocol that will help us to be able to send data to liquid crystal display with just a few connections. So the liquid crystal display has like up to like 16 pins, but we don't have that amount of pins free on our Arduino. So we just use a liquid crystal, an I2C, sorry. We just use an I2C to interface it, so that we just need only 4 pins to be able to communicate with the LCD. So that's like what it does. It just simplifies it for us. Instead of, since we don't have that much pins to spare. Now, we want to use this to display formatted sensor data. Then the fourth objective is that we want to perform a sensor calibration exercise and calculate accuracy, precision, and measurement uncertainty. So after you have gotten a real, you get a thermometer and be able to compare the values, and so see how accurate and precise the temperature reading is. Now for the theory. Who has that up mic? Okay, thank you. Now for the theory, the DS18B20 is produced by Dela Semiconductor, so that's the manufacturer, and it signifies a groundbreaking advancement in temperature sensing system being the first to support a single bus interface. Now, the single bus interface is just the communication protocol. Now, different temperature sensors has the way that the data read from the sensor is transmitted to your microcontroller. Now, this DS18B20 uses one line as data line. Uses only one data line. So you have your VCC and your ground, and then one data line. So it uses a single bus. So there are many complicated, like I said, I2C that we said we are going to use for the LCD uses two wires for communication, uses the clock and the SDA. Then you have your VCC and your ground. But this one only one wire for the data. So is a, like I said, is a groundbreaking technology. So you don't need to have so many pins connected. It's just three wires, your VCC, your ground, and the data line. So this device is distinguished by its low power consumption. So you don't have much. Then it has anti-interference capabilities, ease of integration of processors. So like I said, like it's easy to any microprocessors can work with it. You can use Arduino Uno, you can use Arduino Nano, you can use ESP32, and it has, like I said, it has one wire communication and requires only a data line, ground, enabling efficient data to the efficient direct temperature to digital signal conversion. Can you give me the next slide? So, like I said, so this is the picture, this is the image of the DS18B20. So if you look at it now, you're going to see there are three wires inside this. There are just three wires. Now you see the stainless steel head. That stainless steel head is the sensor itself. Is you can submerge it in a liquid, or you put it near the whatever body you want to take the temperature. It can also read the temperature of the atmosphere as the room temperature. So if you just leave it in the room, it can read the room temperature. So you can actually read the room temperature if you just connect it, if you just leave it out in the atmosphere. And then it has three wires. You see the ground, you see the VCC, I see the data line. So you just connect it's just very simple, like I've seen it. So instead of having so many wires that is complicated and all that, this DS18B that we implemented is just very simple for you to use. So the next slide, please. Now we are going to be looking at the apparatus, and so what are the equipment that we use to build this system. So the first thing you need to get is your Arduino Uno. So the Arduino Uno, we know what the Arduino uses an ATP Mega 320p. So Arduino Uno, we have the DS18B20 model. So it's water resistant, like you have seen here, and then it gets the digital temperature, and then also reads for liquid sensors. So like I said, it's not analog, it's digital, so it's discrete values. And then the third thing we need here is the I2C and LCD. So the LCD is actually the LCD is a different equipment component, and the I2C different components. But like I said, the LCD helps us, the I2C helps us to communicate with the LCD, so that makes it easy. Now, we need the reference thermometer for the calibration. So you calibrate, you check the accuracy, the precision of the distance. And we need a 4.7K ohm resistor. So this 4.7K resistor will act as a pull-up for the data line. So the data line is just connected directly. We connect the data line from the VC, we connect from the VCC using a pull-up resistor, and then the data line. The use of the pull-up resistor means that what it does is that it keeps the data line high until there's a connection. That's what the pull-up resistor does, is it pulls it up. It keeps it high until there's a connection. So we just connect the 4K resistor across from the VCC and then the data line. When we go on, you see the circuit diagram and you understand what I'm saying. Now you see we need a hot water flask and ice. They are just bodies that you will measure the temperatures. So you can just get hot water, you get ice. So we test the temperatures of them, and then we need a multimeter. So it just is to take voltage values. Next slide, please. Okay, now so what's the circuit connections? So for now, you're going to see that there are 5 columns here. And the first column is for components. You see the terminals, the pins where you connect them, and then the explanation of where they're connected to. Now, the first thing we are connecting is our temperature sensor. We're going to connecting it. Like I said, there are 3 wires, which you saw in the image. So we connect the VCC to Arduino 5 volts. So what in the VCC does, the voltage it needs to run is 5 volts. So you just need to take the VCC and connect it to the 5 volt of the Arduino. That's for the power. Then it needs the data line. Data line is connected to D6, but like I said, it has a pull-up resistor. So, but when we see this where the circuit schematic was drawn, you see how that is able to come. How we did that? How it's connected to D6 and still connected to VCC through a pull-up resistor. You're able to see that. And then we have the ground of the temperature sensor connected to the Arduino ground. Then the 4K ohm resistor, 4.7K ohm resistor is connected between VCC and D6. Between VCC and D6. So it's connected on the Arduino 5 volts and then D6. Then we have the L2C. The L2C has the LCD, like I said, is being interfaced with an I2C. And the I2C has just 4 pins. We have the VCC, we connect to Arduino 5 volts as the power. We have the ground, we are going to connect to the Arduino ground. We have the SDA. We connect this SDA, is the data line. It has two wires for the communication itself. It has the SDA and the SCL. The SDA is the data line that passes the information we are going to use. Then it has the clock line. So what it does is that between the signal passing from the data and the clock, it is able to interpret whatever command you are giving to the LCD. That's what it does. That's what I2C does. So this is the connection for it. So give me the next slide, please. Now this is the circuit schematic. So if you look at it very closely, now we have from your left. If you look at it from your left, you see the Arduino, and then you will see the connections A4 to SDA. No, please, A4 to SDA, A5 to clock, that's SCL, ground to ground, 5 volts to 5 volts. Now look at down, you will see how the DS18B20 is connected. See that there is a 5 volt. From the 5 volts, the 4.7K resistor is connected, and then it's connected to the data. And then under it, you see where the data is also connected to the D6. Under it, see where the data is connected to the D6. Then obviously you see the 5 volt also goes to VCC. So the 5 volts goes to 5 volts to VCC, 5 volts through 4.7K ohms resistor to data, and then the data is taken again to D6. So it's from the D6 now that you now start take your readings. It's this is that gives us the readings of the temperature, and then we have your ground. Then, like I said, the I2C is interfaced with the LCD. That's why you see it this way. Where it's drawn, you see the LCD 16x2, and then the I2C is interfaced with it. Please, next slide. Can you hear me? But I want to confirm again. Can you hear me, please? Yeah, like if just can you indicate? I mean, I'm not talking to my.
Yeah, we can hear you.
we can hear you. Yeah, we can hear you.
Meanwhile, as I'm talking, if you have any question, maybe you can probably signify or write it down so that maybe at the end I'll be able to attend to your question. Okay, no problem. Now, please give me the next slide. Okay. Now, what's the procedure? So the procedure is first you're going to open your Arduino IDE. Open an Arduino IDE, and you will go to you go and install a library. There's like 3 libraries you install. There's one that is not here. There's 3 libraries you install. You install the one wire library. Then you install the one wire library. There's each library too. You now install the liquid crystal I2C library on the Arduino. So these libraries now will help you to communicate with it. So the manufacturers of these particular components are the one that has this library, so that you're able to communicate with their components very easily. So now the second step is to assemble the circuit as per connection table. So from that connection table, you saw the circuit diagram. You will now connect the equipment in that manner. Then you upload the source code. I show you the source code in a GIF or so. You see the source code, you upload it to your Arduino, and then you will now start reading the temperature. You take your temperature sensor. Maybe if you want to take temperature of hot water, you dip it in hot water. If you want to take that of cold water, you dip it in cold water. You can take it of the atmosphere. Just keep it in there. You reach the room temperature. Now you see the temperature displayed on LCD. You see how it's displayed on the LCD. You can also see the temperature on your serial monitor according to the code we wrote. Need to know that temperature display is not just on your LCD, but on your system, on your serial monitor, on your Arduino IDE. You can also see the temperature displayed there. So please, next slide. Now, so this is the source code. I just want to quickly I don't know if you can, maybe you can zoom in your own so I can see it properly. And I will explain the code just very briefly. Now, like I said, they're going to be installing you're going to be installing libraries. Now you're going to install you first of all, you will go on your Arduino IDE, you install these libraries, then you include the libraries, the wire.h library, the liquid crystal I2C library, the one wire library, and then your Dallas temperature library. All them, and then you will also set up the I2C. That's what the seventh line of the code is doing. It's setting up your I2C. Then the line 10 is defining what pin our data line is connected to. We use pin here. It can be connected to any of the digital pins. You can use pin 12, you can use pin 10, you can use pin 9. But here we used pin 6 in control. So I want to point that out. It's not like a static something that is pin 6. So, but what we use in the circuit we built, we used pin 6. That's why we defined it as pin 6. Then you see we initialized our one wire protocol and the last protocol. Then in our setup code, you initialize your baud rate, serial begin. Now you're going to tell the LCD to come on. That's what your line 25 and 26 done. It's telling the LCD to come on. It initializes the LCD and then turns on the backlight of the LCD. Then the line 28 is going to tell the LCD what to put, what is going to print. So where is it going to print? So set cursor. It's going to set it to a place. Now there is 0 and there are two numbers in the bracket, is 0 and 0. So the first one is telling it column should it start printing the numbers, and then the second one is on which rule. So on the Unity LCD print temperature sensor, so it's going to start printing the temperature sensor on the first column and write it throughout on that row. Then the 31st line is not telling it, okay, on the second row now write using Arduino. That's it. And then in our void loop, we're going to a request for the temperature. So that's it. The next slide, please. If you just look at what we're just doing is basically we are going to using the source code, we are going to request from the temperature from the sensor. Now when you request it, you will now we declare a variable temp c, and reason why we declare that variable temp c is that it's float temp c because it has to accommodate decimal point. We tell that is I want to make sure that it's not just reading. We want to make it in a way that we want to see whether the sensor is actually connected to the system. So if the sensor is connected to the system, tell us the values are going to be reading from the sensor. But if the sensor is not connected, tell us that sensor not connected or no sensor found. So that's what we did. So when we declare an if statement to get if the sensor is connected, then it's going to get the temperature, print it on our serial monitor, and then also print it on our LCD. Then if else, that's if there is no sensor connected, it will just write no sensor or error, no sensor on our serial monitor and also on the LCD display. So this is the code. Next slide, please. Okay, I think that is all. I think that is all for the listening. I think I should have a video. I don't know how to now play video on the screen. I should share my screen basically and open the video. Just give me like 2 minutes. Let me get the video of this since this system we built. Okay, so I can't actually share my own screen. I'm not a co-host. I just saw it. I can't share my own screen. So I don't know. Sir, can you make me a host? I can share my screen and they will see the video, sir.
Kelechi, stop sharing so I can make him a host. Okay.
Okay, sir.
Okay. Where are you again now? Okay. Okay, you can share your screen now.
I'm having issues. Oh,
I've made you a co-host. You can share your screen now.
okay, sir. Okay, sir. I'm working on it.
Okay.
Oh, sorry. I don't know. It's giving me issues. I don't know why I can't see my screen yet.
You are using your phone?
Yes. It's not working. Oh, okay. I don't know.
Is it a
Kelechi,
big
I think
file?
you have the video of the system. I think Kelechi has the video of the he has the video of the system. I think he can also do it from his own side. I think it'll be easier that way.
Kelechi, do you have the video on your system?
I'm connected to my WhatsApp on my
You say?
My WhatsApp is connected to my system. And just enter the group and share from it.
Okay, no problem. Enter this from the group, please.
I don't want to see it.
Okay.
Okay, great. Okay, so I think you can see the system here. That is our LCD display, and to be reading the temperature in Celsius. And we can actually read the temperature whether in Celsius or in Fahrenheit. So it was a deliberate decision to read it in Celsius. Now, if you look closely above the LCD display, that mode we are seeing that is giving up, that is showing a red light, is actually the I2C. And if you look, you are going to see that it has only 4 pins connected. And then on our breadboard, okay, well, if you had to actually see the breadboard, everything on that breadboard clearly from here. When you see physically, you will know. Then it's reading the temperature. It's the temperature sensor is in my hand actually. So we did have a liquid on ground at that time, I think. And once the temperature sensor, as even as it's in the atmosphere, it's still picking. That's how like how very sensitive the sensor is. Even as it's not in the atmosphere that way, it's just picking up the temperature. So even if you put it in water, you read your temperature and it's displaying there. We didn't video the serial monitor, but if you go to serial monitor, it's in a way that the serial monitor is displaying both the temperature in Celsius and in Fahrenheit. But then there's limitation on the LCD being just it can only display 32 characters, 16 characters per row. So we cannot obviously display Fahrenheit temperature and Celsius at the same time. So we chose to display only the Celsius. So this is your temperature sensor, and I think that should be all. I don't know if you have any question that or anything you need clarification on. You can just indicate. Anyone?
So
Is there any
Yes.
questions
Yes,
for
I do
them.
have a question. I do have a question. What material is that temperature sensor you held in your hand made of?
The material is made of the head. I think the head is aluminum now. Sorry, I said aluminum. It's a stainless steel. The head is a stainless steel. That's shiny part. I said that's stainless steel now. And then the black part is just rubber and wires inside. Does that answer your question?
Okay, and secondly, yes, it does. It did.
It
Secondly,
did.
how long would
How
it
long would
displaying temperature
displaying
before it
temperature
changes to a present
to a
one?
present one?
Keep it in
Keep
hot
it
water
in
now.
hot water now.
What's the time it will
What's
take
the time
before
it
the
will take
LCD will
before the
release the
LCD will
hot
release
water
the hot water
temperature from this
from this
environment to being
environment
freeze?
to being freeze?
Okay. That is dependent on what you program. So on our program, see the temperature, the sensor is always reading the temperature of the surrounding. It's always reading it. But then in our program, our Arduino is going to request the reading it has from it according to our code that the delay is about 3 seconds. So every 3 seconds, Arduino requests a new temperature from it and displays it. I don't know if you understand.
Yes,
Do you get me?
yes, I
Yeah,
do.
he's continuously reading the temperature of the
Yeah,
surrounding.
yeah,
So
yeah, I do.
what we just do is in our code we indicate how long do you want it to take before the Arduino request another temperature from it. You can make it in a way that it requests it every 5 seconds, every 10 seconds. You are the one that will write it in your program.
Okay, I get.
Any other question? Any other question? Okay, you have a question. And what's your question? Are you speaking? I can't hear you. In case you are speaking. Think, Mikey, I think you said you have your question. I can't hear you. So if you are talking, okay, sorry. You said you have a question. Please, can you unmute your mic and ask your question? Okay, please, where is the reference thermometer? Okay, the reference thermometer is not, we not included in the video. You will get a thermometer now and just measure the temperature. It is not like a component that you are going to integrate into the system. It's not a component going to integrate. It's what the reference temperature is for. Like once let me say you want to take the temperature of the water now. Once you have used this sensor now to take the temperature, you now go and you take your reference thermometer and just test it out. So it's not like connected with the system. It's just for you to you just gauge the precision of the temperature sensor. I don't know if you get. Did I answer your question?
I'm not hearing their questions.
He typed it on the chat. He typed it on the chat. He did not say.
Please, I have another question.
Okay, no problem.
In what unit does the temperature
does the
sensor?
temperature sensor?
Okay. So it measures basically in 2 units. It measures in Fahrenheit and in Celsius. So
So displaying on the LCD now, we request someone from the Arduino.
I didn't hear you. Your voice is cracking. What do you say?
So the temperature sensor is sending the temperature of 2 different measures to the Arduino.
Well, the thing is actually sending it, yes, in those 2 different measures. And what we are doing is that we will decide which one to read.
Okay.
We will decide which one to read. So there is a function in the code that is for Fahrenheit, reading Fahrenheit, and there is one for reading the Celsius temperature. So you just read in Fahrenheit and totally ignore taking the Celsius value. You can just totally ignore it if you want. So if what the system, what you want to build just needs temperature in Fahrenheit, just use the function for the height and you will get your temperature, this in Fahrenheit. But then we use the both of them. So it got both the temperature, not just in Fahrenheit, but in Celsius. But what we decided to display on the LCD is just the temperature in It's just the temperature in Celsius. That's what we just had to display only on the LCD. Like I said, there are limitation of character. We don't have enough characters on the LCD to display both the Fahrenheit and the Celsius. It can only accommodate 32 characters. So we are just trying to manage it efficiently. So I think that answers your question.
Yes, it did.
Okay, thank you. I want to take one more question.
Any other question or concern?
Please, Mudu, can you unmute your mic and speak? So that I think this session is recorded. So those that will come, we see it. Can you unmute your mic and ask the question? So I will answer it. Mudu, can you hear me? Please unmute your mic and ask the question so that it will not be lost. Or let me just read the question from my own end. Okay, you're asking what is the real life application of this temperature sensor? Like I said, what a sensor does for you is to be able to is going to allow your system to communicate with the environment. So let's say you want to implement something like a cooling system. For, let me say, drinks or water that you're going to keep in a certain place. So how will you implement it? You need to know, at least your system needs to know what is the current temperature of the water you want to cool. Temperature. And what you will do is that, let me say you want the water to always be at 3 degrees Celsius. That's what you want. So if you use the temperature sensor now to get the sensor value, anytime he reads the temperature of the water and is above 3 degrees Celsius, you can decide to use that data and turn on your cooling system. It begins to cool it. But then once it gets to 3 degrees Celsius, then your cooling system stops. Are you seeing it now? So while you as a human being, if it was you to do it manually, it will come, check the temperature on your system by yourself, you will go. So instead of doing that now, this temperature sensor is able to allow you in feed values into the system, and the system can now make decisions based on the code you have written to it. This is just one application. There's just so many applications of using a temperature monitoring system. That's exactly what your AC uses. What the AC uses, but not this particular sensor. What the AC uses is it reads the temperature of the room, and then you set it. Maybe you set a particular temperature value you want your room to be cool to. Your AC, first of all, checks the current temperature of the room. Let's say it's 25 degrees Celsius. It comes on, and then it starts cooling until once it reaches 16 degrees Celsius, it stops cooling. Once the temperature increases again, it cools. So that it keeps repeating that process. Recool to 16. Once it reaches 16, it stops. Start cooling again to 16, it stops. That you yourself, that is the human being that is now there, you will not notice it. but your body only feels at 16 degrees Celsius. So that's what you can use temperature monitoring system for. There are also many applications for it. I just gave you 2 applications. One of the biggest one is in HVAC, that's in cooling systems. It's used in industries, it's used also in cold rooms, in freezing fishes and all those cold this thing use, seafood, all those stuff. So that's just some applications.
Okay.
So I think I answered your question.
Okay. Somebody is asking, where is the reference thermometer? Reference thermometer is just used to for calibration. When you come to the lab, part of the thing we are going to buy is a reference thermometer. What it means is that after programming the temperature monitoring system, we want to compare the error between the read values and the reference thermometer. If there are differences, it will be corrected. So it's just for calibration purpose. So just be sure that what the program temperature sensor is reading is consistent with already calibrated standard thermometer. Is that clear to you? Then, okay, I think they've done well. Is Esther in this meeting now? Esther, are you in this meeting?
Yes, sir.
Okay. Are you ready?
Yes, I'm in the meeting.
Okay, before she does her own part, okay, Rada, are you ready to show them how to include, what do you call it? The header files, zip file in Arduino IDE.
The libraries.
Yes. Are you prepared for that?
Oh, not yet, sir. Not yet, sir.
Okay, so we'll go ahead. So what we are going to do, Kelechi, project your screen again. Kelechi, project your screen again. Emmanuel, thank you very much. That was a good presentation.
Thank you, sir.
Okay, I think I can project from here. I can project from here. I think I have this right. Let me project from here. Can you see my screen now? Can you see my screen?
Yes, I can see your screen.
Okay. So what we are going to do in implementation, somebody asked where we are going to apply it. We are going to narrow this project down to this product, down to automatic water heating system. It's going to be user-friendly in the sense that when you come, you will specify the temperature. We are going to use a heater or what is generally called a boiler. Is that correct?
Yes.
Yes, sir.
Boiler you normally use in heating water. I mean, we don't know what to call it, but during our days, some people call it ring, heating ring, but it's actually water boiler. That is AC actuated. So we suspend it in a bucket, also suspend the temperature sensor. It's going to be constructed such that when you come, you specify the temperature through Arduino, the temperature you want the boiler to heat the water up to. Probably you don't want it to get up to 100 degrees centigrade. Probably you want it to remain at 60 degrees centigrade. You specify it, and then the system accepts it and begins to heat up. Once the temperature of the water gets to that threshold, the heater will go off. Okay? And possibly you specify the minimum temperature range, or what is called the minimum threshold, probably 50. So you want the temperature of the water to remain within 50 degrees centigrade and 60 degrees centigrade. It becomes a closed loop control system. So when it is up to 50, up to 60, it turns off the heater. When it is below 50, it turns on the heater. Is that okay? Does it make sense to you?
Yes, sir.
Yes, sir.
So that arrangement will replace this hot water flask, because we're not just building something just for building's sake. We're going to replace it. We'll do a little construction, get water boiler, and then get a delay actuator that will interface with AC to be able to actuate the boiler. And then we get the information from the temperature sensor to know when to either turn off the temperature, the heater, or turn it on. So it becomes a control, a full feedback control system. You've done control system. You've done closed loop control system. Have you done any course on control system? Nobody's responding.
Not really, sir.
Oh, you've not done any course on control system, but yeah, you at least you experience control system before you begin to study it. That's what we are going to do. Emmanuel did justice to this. And I mean, everything was wonderful. Emmanuel, how many months have you people been with us? Or rather weeks?
Yeah, is currently this is the 6th week, sir.
Which week?
The 6th week.
6th.
Yes, sir.
Okay. So, to the rest of the students now, you can see that these things are possible. It's possible to learn this thing as a student. You don't really need to be a lecturer for you to learn this thing and teach it. So for the just roughly 1 month they've been with us, they're able to capture these things, and can see the way he's presenting this thing as if they have been on it for several months. But that's a result of good coaching and consistency in studying. So you can do your IT with a smart world. During your IT, you can do your 6-month IT with Smart World RC. You can also engage in trainings with them. You can also buy your components If you have your components you want to buy, you can order through us. We also sell Arduino, just components. If you want components, and you can order through the company. The company will get you original components. So that's that. I will be getting across I don't know, this particular topic is for group what? Let's see.
Group 3, Group 3.
Group 3, sir.
No, it can't be group 3. Let me check the manual. This is for, let me just check. I know we have done for group 1 and group 2. Please take note of your projects for different groups. Group 5 is wireless door alert system. Wireless door alert system. That's group 5. We are here to do their lecture. Then group 4 is temperature monitoring system. Group 4, that's what is treated today. Then group 3 is automatic street light system. I think we have done we have not taught you automatic street light system, but we have concluded that I have concluded that with the IT students. So by next week now, please Kelechi and Emmanuel, take note. Are you listening?
Yes, sir.
So by next week,
Yes, sir.
you'll be making a presentation on another presentation on automatic street light system. That's for group 3. But I think what will happen is we have to articulate the cost of automatic street light system and temperature monitoring system, and they send it to group 3 and 4 so that their components will be ordered once. Then we now know that the components that have not been ordered will be the last group. Okay? That's that. But it's important that everybody pays attention to all the models. You know, in your exam, you will not be saying I participated in group 1 or group 2. Exam, you are expected to answer questions. You get the point? I hope you got the point.
Yes, sir.
If you can participate in all the group, I mean, personal stuff, fine. But
Yes, sir.
don't just say my group is group 1 and then the exam is coming, you say I participated in group 1. Nobody will do that. Nobody will set specific questions for anybody in any group. It has to be common questions. That's why the course is being, theoretically, the course is being taken generally, but practically, because we want you to gain a specific experience, Now say we divide you into group to just be sure that somebody goes on with specific something. Match, you are raising up your hand. Go ahead.
Yes, sir. So, sir, you mean that we are supposed to know everything about all the projects that each group is doing?
Yeah, you are supposed, at least from theoretical point of view.
Okay.
Every one of you is participating. Every one of you is supposed to participate in the theoretical classes going on. You get the point?
Yes, sir. Thank you very much.
So the practical aspect of it will be graded based on your participation in your group projects. But then the exam is purely theoretical. So, and the question can come from anywhere. Okay. Prince Chikeze is raising up his hand. Go ahead. Prince, okay, it's like he has put down his hand. Match, your hand is still up. You have another question?
No, sir. Sorry, let me raise it down.
Okay. Somebody say, please give me your WhatsApp number. I have some questions. Ask your questions here now. I'm a very busy person. No.
Good evening, sir.
Good evening.
Good evening, sir. Sir, please, I'm from ELE. I'm asking based on Group 2 because I've not really gotten any updates about what we are doing.
Group 2?
Yes, sir.
Group 2 is working on which project against math? RFI-based attendance system. Is that correct?
RFID attendance system. Yes, sir.
We have concluded your
lectures.
What is it?
Lectures.
We have concluded lectures on that now, and the prototype has been built.
Yes.
Emmanuel, can you give them updates on smart attendance system?
Okay, sir. I think the theory part of it has been done. The RFID system is just we have an RFID tag. So each of them just have a unique identification tag and it has a unique number. We'll read each tag, we'll read the number and see whether it's what is in our database. If it corresponds, we grant you access. So in case you are a student now is coming to class, so if you register for the class, your UID of your card that will issue to you is in our database. Once you scan it, it will now know that you came and then your attendance will be marked. That's like a breakdown of the system. It's just simplistic, but there's a whole lot, but I can't say it like. Yeah.
So the what do you call it? Just a minute. We just the components came in on the components came in on Saturday. Can you see this now? Can you see this?
Yes, sir, we can.
So this is RFID tag, and there are 5 of them. There are 5 of them. Okay, this is 1. This is 2. This is 3. This is 4. This is 5. And then inside it, if you look properly, there is RFID reader. I don't want to open it. You will be the one to open it when you come to the lab. You will be the one to open it and implement it. We have implemented one. So when you come, we will guide you on how to implement it. The challenge is how to manage the crowd. That is just what is just trying to think about now, how to manage the crowd, because we don't want the the conventional thing we do here. When students come to the lab, they will not learn anything. You people have to come in batches, but we are going to structure it. Thank God we started in time. So when you open this, you will see the reader and the tag. Each one has one reader and two tags. And then the controllers are here. What I mean by controller, I mean Arduino boards. Arduino boards are in the store. I can't go to the store now. So the idea in the store, many of them. So what you need is 5 pieces. What other component do we need in that RFID? Of course, the packaging box, something like this. Something like this. Can you see this? Can you see this?
Yes, sir. So is the component coming with this box?
No, we bought all of them now.
Okay.
We're talking about product development.
Yes,
One of the aims of this course is for you to see how these things are assembled. You see that it's not a rocket science. It's something you can actually do. Okay, one of the components of the RFID stuff is LCD. I took 2 LCD to the office today. I mean to school. I didn't come back with it. But these are LCD. This is LCD. Okay. This is LCD. This is LCD. I think the water level controller doesn't need Does it need LCD?
The one we did the one we presented today, we used LCD. Just indicate that water is not there.
The one we did is needs LCD abi.
Yes, sir.
In that case, it requires 5 LCD. That means you are going to buy more LCD. Well, this one will need 5. This one will need 5. Is that correct?
Yes, sir. Also, sir, the RFID also has a buzzer and then LEDs for
the buzzers
indication
are
of...
here. I know the buzzers are here. The buzzers are here. Look at the buzzer. I don't know whether you can see. Anyway, some of you may not know what is a buzzer. But can you see this now?
Yes, sir, we can see it.
So this is a buzzer. When you come to the lab, I've approached these boys to be able to assist you. So when you come to the lab, you are going to, group by group, you are going to integrate this in yourself and program them by yourself. Especially with respect to this RFID based attendance system, because it's something you can put together by yourself. Temperature monitoring system, you put it together by yourself. Even water controller. The only thing we are going to do for you in water controller is that we are going to give you the person that is building the water tank has already started. So, but as per the control, you are going to do it yourself. If it means coming on Saturday there, you come on Saturday and learn something. You get the point? This is your water pump. There are 5 of them. 2 are in schools. 2 are in school. 3. This is 3 now. 3 are here. So when you are coming for your practical, each group will have their own destiny, which you are going to implement. This is your part of your. What is this? Who can guess? Who can guess what is this? Or you are not seeing it clearly?
Yes, sir, we're not seeing it clearly.
Eh?
We can't see you again. Let's see you again.
Can you see this?
We can't see. Okay, I'll see you now.
You can't
Yeah,
see
it
it.
looks like
controller.
It's not
like controller, but it's not like multiple control.
Emmanuel, do you know what is this?
It's not very visible.
It's not very visible.
Is that not an Is that not an I2C?
It's I2C now.
I2C
now. Model for
Yes, sir.
LCD. So that's that. We will schedule group 1, either group 1 or group 2, whichever that comes first. We will schedule you for practical next week. I don't know. What is your schedule like? What time are you free on your timetable?
So I'll get back to
Friday.
the WhatsApp, sir.
You say?
So I'll get back to you on the time because the other departments are here. So we'll talk.
It will not be it will not be everybody. I think each department, for example, if we are going to start with group 2, because the level, what is time? 9:19. The water tank is not yet ready, but at least RFID can start. It's not going to be everybody. What do I mean? RFID, for example, you have group 1 cut across every department. Is that correct?
Yes, sir.
Good.
So RFID is group 2.
It's group 2 now, I know. It's group 2. You will have it cut across every department. Is that correct?
Yes.
Now,
Yes, sir.
and each department, I don't think there is any department that is less than 25. Is there any group that is less than 25? Machuku, you are this thing. What do you call it?
My department or
Your department, group 1. Are they not up to 30?
They are up to 30. Group 2 self is 37.
That IEEE office, the capacity is 35.
Oh.
So I don't want people to just come there without learning anything.
Okay, sir.
So each department, each course rep should be able to say, so time within the week we are free. So when you are free, you come there. We'll be dealing with this practical department by department, not group 1. Everybody will come there. If everyone comes there, then nobody will. In the first place, it won't even accommodate you people. Also, the essence of this project will have been defeated. I don't do that kind of thing. So, since by God's grace, we have raised 3 people there that can assist you. Even if I'm not there, the practical will be going on. So you check your timetable. For example, mechatronics between Monday and Thursday. Between Monday and Thursday, please don't include Friday. Friday is for final year projects. Final year projects are going on there on every Friday.
Okay, sir.
So just remove Friday from it. Monday to Thursday, which time are you free? When you specify the time you are free, we now know that you are coming. So when you come, 30 of you or 35 of you will sit down. Your components will be given to you, and you have to implement it by yourself. Do you get the point?
Yes, sir.
So it's now less for each course rep to give us your time. When we are done with group 2, for example, why I'm saying group 2 is that group 2, their product, everything is ready for them to start their practical. For group 1, you cannot start that practical until the water stand. I mean, yeah, the water stand, the 5 water stands are ready, so that when you come, you have to see what you are controlling. And then you write algorithm that will control the water pump by yourself. So possibly we are going to start with, in fact, let's start with group 2 next week. So you give me your schedule. We schedule you for practical. When you come, even if I have lecture, somebody will be there to attend to you. That's the way it's going to happen. Is that okay?
Yes, sir. So I'll get back to you on time tomorrow.
Okay. Any other question? Please ask your question. Don't chat. If you have question, just ask your question. I don't have time to begin to look at the chat now. If you have question, just listen.
So I have a question. I didn't hear what you mentioned for group 1's practical.
Chike there is still raising office, and go ahead.
Like, sir, I said when you are mentioning all the groups, when you are mentioning all the groups, your practical, network dropped me down. So I didn't hear what you mentioned for group 1, their practical will be. So I heard from group 3.
I didn't hear you clearly. If somebody heard him, can you repeat what he said?
He's asking what group 1 practical will be.
He's doing what? He did what?
He asked what group 1 is going to be producing, like their project.
Right. Is it from my end? Machuku, did you hear what they said?
No, okay, sir. No,
what group 1 practical will be, sir?
Okay, he's asking for group 1 practical, like what it is. I think Benjamin posted it on the group.
Group 1 practical is water level controller.
Water level controller, yes.
Water level control system.
Okay,
what it means is that you have not bought your manuals. That's what it means.
Yes, sir. We are here to buy it.
And you know you are going to come to the lab with your manuals.
Jesus.
Yes, now you are going to record. You are going to record your values in the lab now.
But you know that okay, we can buy it next week, but school has been closed for 2 weeks now.
Yeah, but school will open on Monday now.
Yes, sir.
Exactly.
The practical is not starting this week. I hope I am clear.
Okay. Yes, sir.
The practical is not starting this week. It's starting next week. But then we need to have your schedule so that we know that you are coming.
Okay, sir.
Okay. Who is raising up his hand?
Okay, sir, I'm the one.
Good evening, sir.
Go ahead.
Sir, please, can we get the slide for today's presentation?
This meeting is being recorded.
Okay, so where can we watch it?
When I upload it on my YouTube, I will send the link to the platform. Then your course help will get to you.
Okay, sir. Thank you, sir.
Okay. Benjamin.
Yes, sir. So about group 1, the students you said will go and watch the welders fabricate the water level stand. Is it still going to be possible?
How many of you can volunteer, because they are working on it already?
Yes, sir. We can volunteer 2-3 students.
Among the group 1, the people that want to volunteer to come to go and observe what is going on, you chat me up.
Okay, sir.
Or rather, because if all of you begin to chat me up, it will become something that I may not be able to manage. Submit your name now to your group leader. Is it group leader now or course rep now? I mean, what I mean is that I need a coordinated something. I don't want to be dealing with students one by one. So those in group 1 that wants to participate in what is going on there, you let me know so that I will discuss with the person managing the project, so that you people can go and see what is going on. You get the point?
Yes, sir.
And even when they are finishing the whole thing, you can come around and see what they are doing, and see how they are packaging you. At least, even if you don't do it, you observe what they are doing.
Sir, when would it happen?
They've already started the process, and that's why I say you indicate interest so that I will discuss. I'm not the one managing that aspect of the project. I will discuss with the person managing the project and know when it's convenient for people to pay a visit to them and know what is going on. I can't be jack of all trades now.
Okay, sir.
Yeah. Okay, in absence of any other question, it's 9:30. I think we will call it a day. Okay.
Thank you very much, sir.
When we articulate the cost, we will send it through your cost rep. The cost of implementing temperature monitoring system, we will send it through the cost rep, and your cost rep will get to the group leaders. When you pay your money, we secure your components. Thank you. Okay.